I'll try to see if I can post this. Okay, so you guys all see my screen, yes? It would be nice if here and there someone can turn on mic and say something. It will be difficult for me to check both the chat box and doing this. So, the style we have today for this review is that every question comes up. I'll give you a little bit of time just to understand what's going on, and then we go for the next question. I have prepared a whole bunch, and then if we need more, I'll try to get this done at point, and then we get more things. Okay. So this is one of those type of questions that you may encounter, yes, using trig functions and evaluating them. How about I give you this, let's say, 40 seconds, 1 minute. You just trying to understand where you are so that when I start the solution, it doesn't look completely from other worlds. So just go ahead, please start, and then I will go ahead and explain everything in details. Oh, mm. Okay, so the questions like this comes from, you remember we had the idea that, okay, if you know one, you know all. You know one, you know all. This is about the trig functions. And as you know, there is a lie in that sentence. We have to know where um, the angle is. So which quadrant. If we know that, then we can work with it. Okay, now, so we are trying to find what is tan of this angle. Yes. What is that angle? That is an angle which is cosine inverse of -2/5. So for those who are focusing only on the special angles, that is what we need to do. But here we are not asked to find the cosine inverse of -2/5. What we are asked is find tan of that. So in other words, we know that cosine of theta is -2/5, and we are asked to find what is tan of theta. So you have to see this. We are not trying to find what is cosine inverse, what is the value of theta. What we want to find is what is the tan of that theta. And for this, now, first thing to see is this, that which quadrant is this at? Cosine of theta is negative. Remember, all students take calculus. So everything is positive here. Sine is the only positive one. Tan is the only positive one. And here is the cosine is the only positive one. Since cosine theta is a negative number, that means that we are either in the second quadrant or in the third quadrant. Well, actually, we know more than that. Can anyone say how we can choose between which quadrant? Like here, are we going to go on the first quadrant, or we are going to go, sorry, are we going to go to second quadrant or third quadrant? There is an answer already there. Can anyone mention it? It would be nice if you can turn on your mic for that.
Second.
Sorry, second, can you tell us why?
Is it because the domain is restricted?
Because what? Sorry, I couldn't hear.
Oh, the domain is restricted.
I see. So from this, we cannot say that, but from this part, remember the definition of cosine inverse. Cosine inverse to be an invertible function, we have to restrict the cosine function is to this interval which went from 0 to pi. And this is the convention, and this is the standard convention that we go from 0 to pi. Since cosine inverse, so we take the one-to-one domain of cosine, and then we use that one-to-one domain to find inverse of cosine function. So this means that cosine of an angle is x if and only if x is cosine inverse of theta, and sorry, the other way around. Why I'm writing that way? If um, if theta is between 0 and pi, then we can conclude that. So this means that already we know more than that. We know that the theta is in the second quadrant. And as a result of that, As a result of that, well, what will happen is that tan of theta, now we are in the second quadrant, and we know that only out of sine, cosine, and tan, these three, we know that only sine is positive there. So then tan would be a negative number. So tan of theta will be negative number. That's one information that we needed to get over and then figure out the other stuff. Now that tan of theta is going to be negative number, I can go ahead and try to use the triangle thing. Well, you can use the correct triangle, or you just set it up as you like. So this is theta there, yes. And then here I have adjacent. This is a bad triangle. This doesn't reflect what I am looking for. So it will be probably like more like this. So here cosine, which is adjacent here over hypotenuse there, is going to be 2 over 5. Well, with the negative sign here. In other words, here is -2, and then I have to pick something for y such that makes this hypotenuse pi. And that will be 25 minus 4, which is -2 and root 20. So then we found y actually. What we found here is This is root 21. And now I am trying to find tan of that. So tan of theta, I can use these coordinates here that we have. I can say that, okay, this is opposite over adjacent. So it's root 21 over, well, if it was triangle, it would be just 2. But we know that we have to make it -2 here just to make everything work. That's how we go from only first quadrant to all other quadrants. So that means, yeah, I'm dealing with this number. And going back to the question, this was what it was asked, that tan of cosine inverse of -2/5 is what? It is -21 over root 21 over 2. Any questions, any comments here? We can stop it a little bit and then see.
Could you explain how you like just go back over again how you know it's in the second quadrant?
Okay, sure. So first thing is that we notice that here, this guy, yes, cosine of theta is negative. Cosine of theta being negative means either it is the second one or the third quadrant, yes? But we know something more than that. We know that theta is cosine inverse of -2/5. To be able to define cosine inverse, we had to restrict the domain of cosine function so that it is a one-to-one function. And in this case, remember the way it worked was you go from 0 to pi, you pick that domain. This specific one-to-one domains you have to know for all the functions. And in this case, you see that, okay, this is from 0 to pi, and this theta, which is cosine inverse of that, must be in that one-to-one domain of cosine. It is in the range of cosine inverse, or equivalently, it is in the domain of um, in the domain one-to-one domain of cosine. So that means that while the third quadrant is gone, it cannot be in the third quadrant. Theta must be either the first quadrant and second quadrant. Maybe I should have done the black shading is for the one-to-one domain of cosine, either it's in the first one or second one. The red shading is for negativeness of cosine domain. So that means that, okay, so we are doing here. Does that answer your question?
Yes, thank you.
Any other questions? I can take one more before I move on. Sending questions is very to things very difficult. Oh yeah, I see. You guys are chatting there. That's always good.
I
Yeah,
have a question.
sure, please.
If the domain of cosine would be, sorry, if the range of cosine is negative 1 to 1,
Yes,
wouldn't that be the domain of cos
cosine.
inverse?
That's right.
So why aren't we using the domain of cos inverse to find this? Because we're working with cos.
Domain of cosine inverse is here. It is already satisfied, yes? Cosine inverse domain is what are the possible values as input into cosine inverse. It is already there. It is known. It's -2/5, which is a number between -1 and 1.
Okay.
Here, it is about one-to-one domain of cosine, which would be the range of cosine inverse.
Oh, I see. Okay. All
Yeah,
right.
that because you see it says that theta here, theta is cosine inverse of something. That means it's in the range. So that's how all these things are related.
Okay. Thank you.
You're very welcome. So I think I will move to the next question again, giving you some time. But that was one of the questions I picked, and I think it's going to be helpful in general. Again, I won't be able to check the chat, so make sure that you do it. You ask or just let me know in some ways. I'm not checking the chat. Okay, let's quickly do a transformation of the graphs of the functions. Just a quick review of one of the review material. I'll give you again 45 seconds, 1 minute, just to start getting the whole idea of where we are, and then we go from there. Okay, I'll just walk you through the steps we are doing here for the transformations, yes. So I know how to sketch e to the power x. Now, I want to go from this to whatever the function we have, which is, say, I don't want to write it here because it may get longer than that. This. Now, let's see how this works. So first thing is that I will change x to 2x. Yeah. So then in that case, it will be my e to the power 2x. Now, if I change x to x minus half, then I will have e to the power 2, x is changed to x minus half. But that part is the same thing as e to the power 2x minus 1, which is what we have in the exponent. Then the next move is you multiply the whole function, which is e to the power 2x minus 1, by 3. So you send f to 3f. So that will create, sorry, this f is not that f. Maybe I should denote these guys properly. So f1, this is f2x, f3x. So now I'm sending f3 to 3f3. And that will create f4 of x for me, which is 3e to the power 2x minus 1. And then the last step is that you send f4 to f4 minus 2. That is our function f of x. So by writing this down, now I know that I'm doing some transformations here, and I'm getting what we are looking for. It's starting from e to the power x. When you multiply x by 2, what kind of transformation is this? So we have to explain this. In this case, can someone mention what is the transformation that sends x to 2x?
Is it horizontally compressed by 1 over 2?
Thank you. So horizontal compress, or what's the word I usually use? This is stretch, and I don't know. Okay, yeah, compress, I'll use that by factor of 1 over 2. Then when I shift x, when I send x to x minus a half, basically I am sending, I'm doing horizontal shift, but how much half unit to the uh, to the to the left. So in other words, my wait, my zero value will go to the right, yeah. This is, I'm shifting things to the right. My old negative half will come to zero. So it is, everything is shifting to the right. Now, multiplying the function by 3, this is vertical task, and here we are stretching by factor 3. And then at the end, I'm subtracting 1 from the whole, sorry, subtracting 2 from the whole function. This is again vertical shift downward 2 units. Yeah. And that's all I need. Was there any question there? Well, then I can go ahead and then step by step follow the changes I have here. Okay, so I have this, I draw, okay, e to the power x, we know all, it goes like that, at 1 is that. Then we get this, copy, then paste. Oh, now I want to shift everything to the right, so I need to pick this and shift it half a mark right to make sure that we have everything in place. Now this is at half. And then I take this, again, copy, and then paste. And then here now I need to stretch vertically. Oh, wait a minute. I think I dropped one step there, yes? I think I dropped, I didn't do this step here. So maybe I should go back, do this. I mean, come on, you all know what I'm doing, yes? I try again, copy, paste, then I'll do, oh, this is compress horizontal because it's in X. So I'll go, that's the compression. Now I take this, copy, and then paste. I do, okay, shift. That is cool. Now I'm shifting half again to just keep the record of the important points. So this is now half. Then I take this, copy, and then paste. Then I do vertical stretch. So everything will go 3 times up. And now that point 1 is turned to the point 3 because it's multiplied by 3. And then I have, oh my God, I think I made a mistake there doing copying into the thing. Okay, well, this is last step. Hopefully that will be paste. And then we have this guy here. So now here I have to push everything or shift everything down, meaning that I have to take this There's a 3 there. Okay, 3 needs to go to 1 now because we shifted everything. Now this is 1. One thing that can clarify things a little bit more is that that horizontal line that we originally had now has to come to y equal to negative. Any questions, any comments here?
Do we have to show the transformations on the midterm?
If it is short answer question, you have to walk through the things, yes? Like here I am doing here I'm showing both formula wise what happened, and I'm writing down the details. And that is how you can say, okay, I have to do the graph, definitely, yes. And I saying mathematically what happens, descriptively what happens, and then move to the next one. So I think if it is short answer, you have to walk through all these steps.
Okay, so I have to write it down and also draw the graphs with the transformations.
That's true. Yes. That's
Okay,
true. Yeah.
all right, thank you.
No. Any other questions?
Will our graph need to be like perfectly correct, or
No, I mean, look, I myself, I'm doing what? I'm doing not the best thing, but what is important, I think, if you have the descriptions ready, yes, so this is where the description will save you, yes. So this is this, this is that, this is that, and this is that. The only thing I would suggest in questions like this, keep track of like a few point how they're changing. For example, here 01 was we were tracking all the time, yes? I was trying to update it each time. And at the end, I noticed that, oh, maybe vertical asymptote, which up to this point always stayed at y equal to 0, could also be a helpful thing if I add that there. Does that answer your question?
yes, thank you.
Okay, then let's move to the next question. I will leave this like that. Find the domain of this function, ln of that. Again, 1 minute just for you, just to see where we are, how you can start, then I'll explain the rest there.
Oh, I'm sorry, Dr. Ghorbanpour.
Yep.
Can I see the first question solution again?
Let me do it after this is done, because now everyone is trying to use that. After this solution is done, then I will go up, remind me, and then I'll begin.
Okay, thank you.
Yeah. Okay. let me now start. So what do we need to know? Remember the conditions that we had for domain. The earlier conditions were square root has non-negative domain. The denominator cannot be 0. And then when we added inverse function, you have to keep track of the thing. So here, the fact that you should recall is that domain of ln, or in general, log function. Oh, that's bad. The log function is similar to square root, with one difference is that it goes it includes only positive numbers, not 0. 0 is not included. In square root, 0 is included, but not in this one. In other words, domain of this function here is all x's in real line such that whatever we are plugging into our function, the function that we are plugging into ln, that is positive. The that's the condition, yes. Ln only accepts positive numbers. Here, what we have inside ln function, it's just a polynomial. It accepts anything you like. The domain of the inner function is the whole real line. But now you have ln applied on it, so it means that we can only pick the positive side. To figure out what are the x values that gives you that, you have to do the sign table, or what do you call sign chart, yes, for this function. And for that, you have to say, okay, now look, I have to go ahead and try to figure out where the question, or what we are aiming to find, is where this polynomial is bigger than 0, or it is positive, yes? Now we want to figure out where it is positive, where it is negative, and where it is none. So we start with none, which is where it is 0. And for that, you can decompose this, and you see that, okay, sum of two numbers, negative is -3. When you multiply, you get 2. So you get -1 and -2. You add -1 to -2, you get -3. When you multiply, you get 2. So from that, you get two values. X is equal either 1 or x is equal to 2. Now, this is good. So I have two values. My sign chart is going to be like this. From -infinity, x goes to 1, and then 2, and then it goes to plus infinity. The function I'm dealing with is 0 here, 0 there. Now I have to plug in sample points. For example, x equal to 3 here, x equal to 1.5, and then x equal to 0. If you do that work, you will see that, oh, this is going to be positive, this is negative, this is positive. Yes. And remember, what we were looking for was where it is positive. So for us, it's going to be here and here. In other words, the domain, or the part that makes this guy's positive, are x's from -infinity to 1 and from 2 to plus infinity. One may say, oh, what does that, should we include 1 or 2? Well, here actually we should not include 1 and 2 simply because they have at those points x squared minus 3x plus 2 is equal to 0 and ln is not defined at 0. And that is the domain. So domain of the function is from negative infinity to 1 or from 2 to positive infinity. Any questions, any comments from this? Okay.
Just to confirm, sir, what is the range of log function? Could you please tell me?
Okay, so log function, you should know the graph for. This is maybe a quick review of this. So remember, log function is, or ln function, let's say the natural one, yes. Ln is inverse of e to the power x. And when you have inverse, basically you find the graph reflected with respect to line y equal to x. So that gives me the graph of ln function, which will go like this, and then we'll go down. And that is the graph. Actually, this goes all the way up. So here it goes up. So that means that the range of, in general, all log functions, but I draw only ln, is from negative infinity to plus infinity. Domain of them is from 0, only at 0 to plus infinity. And keep this in mind that range of a function is equal to domain of its inverse. And that you should already know that e to the power x is defined everywhere. And domain of the function is range of its inverse. And that's also e to the power x only generates positive numbers. Does that answer your question?
Yes, thank you very much.
You're very welcome. Any other questions? Any other comments? Someone asked for question 1, solution for question 1, maybe screenshot, because I have to move down now.
Okay, thank you.
You're welcome. Okay. So let's get to the last question from this part that I included here. Maybe we can do more if I get some time at the end. But I think this is my plan, that this is the last question. Let's find inverse of this function. I'll give you again 45 seconds for you, and then I'll do the work on the tab. Okay. So remember that a function has an inverse if it is 1-to-1, at least in the setup that we have. And basically what happens is that you want to say that, okay, 3e to the power x plus 1 over 2 minus e to the power x. This is how x is y is related to x. Now you want to switch this relationship. So in other words, you want to write x in terms of y. So you want to see if you can write this in terms of y. So in other words, you're trying to solve this for x. That is what it means work-wise. Solve it for x. And that means, okay, so we do y, 2 minus e to the power x equal to 3 e to the power x plus 1. 2y minus y e to the power x is equal to 3 e to the power x. What I'm trying to do here is that I want to collect all the terms which has x in one side and then try to isolate. Yes. Now, okay, so this term has x, this term has x. So I bring both one side, so I can do minus y e to the power x minus 3e to the power x equals, this goes to the other side. So that came there, and that's 1 minus 2y. Now, we factor out e to the power x. And then e to the power x is 1 minus 2y over minus y minus 3. Or this is the same thing as saying that 2y minus 1 is y plus 3. So you just apply, let's multiply both numerator and denominator by negative sign. That's what you get. We are not done. We have found e to the power x in terms of y, but I have to isolate it. I have to write x in terms of y. This is e to the power x. How do I get rid of e to the power x? In other words, if I have e to the power x, what operation will give me x back? Can anyone tell us that one?
Is it ln?
Ln. And why is that? Because ln and e to the power x are inverse of each other. In other words, if you have e to the power ln of x, that will be x. If you have ln of e to the power x, that will be just x itself. So this is in general, whatever expression is there, you can do that. Now, as you suggested, I can take ln of both sides. I cannot just take ln of one side. So that is how I keep the equalities. Now, ln of e to the power x is x ln of 2y minus 1 y plus 3. That is what we found, yes, and that's the basically how we write x in terms of y. But in the form of the equations that we have, this means that I have to write down now what is f inverse of some variable. Here, the f inverse is written in terms of y. And remember, y or anything I put in here is just a placeholder. So I can swap that with any variable I like, including replace it by x. Well, I know that you may know this in different orders. Some of you may swap x and y at the beginning, which I don't like it, but it is it is okay. Like, I mean, that work-wise, it's okay. Or sometimes when you get here, you switch X and Y. But for me, actually, what matters is this, that you understand that this is F inverse, X is F inverse of Y if it exists, yes? Now I can write it that way. Once you have the function, the input in the function has no meaning other than just it is a placeholder. So I can replace it by any variable I like. Any questions, any comments there?
Professor,
Yes.
can you just swap the y and x to begin with and then just solve it that
Sure.
way?
Yeah. That also would make sense. But I mean, as I mentioned, mathematically, that swapping is not essential. It's just for us because we always want to have function as function of x. That's why people say at the beginning you do it, doesn't matter really. Any other questions? Okay. So I picked all those questions for this part, so this review part basically. I hope that was good. So we are moving to the limit part now. I have a whole bunch of examples for you for the limits. That's nice. Yeah, okay. So I'll have 1, 2, 3, 3 just evaluate the limit. And then we will have a whole bunch of related questions, including horizontal, limit at infinity, horizontal, vertical, and a few more things there. Okay, so then let's start with the first question. I will give you about a minute to figure out what we are going to do here, and then we go from there. Okay, so let's go back here. So I'll solve this question actually in two ways. Why does it come black? I don't want black. Okay. So I'll go with method one. So the first thing here to note is that when I plug in the limit, or sorry, if I do the limit as x goes to 2 of the numerator, it is a polynomial. So the polynomial substitution theorem says that this is nothing but you plug in 2 there, and that is 0 to the power 5 plus 20 minus 20, which is 0. Well, sorry, I had to start with the denominator. That's my fault. Because the reason we start with the denominator is that we see a quotient there. We want to use the quotient law, but the quotient law holds when the denominator, the limit of the denominator is not 0. So you get you have to get the limit of the denominator first to check. Here, if I do first the limit of the denominator, which is the right order, logically, that's the right order, then I see that, oh, the limit of the denominator is 0. Yes. So then as a result, we cannot use quotient law. I will write Q law. And then to be able to proceed, I have to write down, check the limit of the numerator. So what happens here is that limit of the numerator is also 0. So now I have to go ahead and try to see how can, or where am I first, which would be, let me write this. Remember always 0 over 0 is not a result, it's a status. I have to report, I have to say that this is 0 over 0. It means that, well, I need to do something to resolve it. And remember how we did this kind of things, especially for the polynomials, we always went with factor it, cancel it, yes. Factor, I'll write it here, and cancel. So factor numerator and denominator and cancel the vanishing factors. Which when x goes to a, it's x minus a. So in this case, now I have to factor x minus 2 because x goes to 2 here. And in the denominator, I have already the vanishing factor, x minus 2. In the numerator, I factor, well, look at this guy here. This is 5x squared minus 4. Yes. So, x minus 2 to the power 5 plus 5 of x squared minus 4 is x minus 2, x plus 2, yes? Now I can factor that out because I have x minus 2 here, and I have x minus 2 here. Each term has the factor x minus 2, so I can factor out x minus 2, x minus 2 to the power 4. I have taken 1 plus 5x plus 2. And then x minus 2, x goes to 2. This cancels. Now we factor and cancel. And what we get the next step is limit of whatever is, because there's nothing left in the denominator. It's 1 in the denominator. So I'm dealing with just one polynomial, long, strange polynomial, but it is a polynomial. And then I can use polynomial substitution law or theorem. And then I get 2 minus 2 to the power 4 plus 5, 2 plus 2, which is 0 plus 5 times 4, and that is 20. Any questions? Any comments here?
I just had a quick question.
Sure.
For the exam, if this was like a short answer question, would you want us to write like sub-polynomial law and all
Yeah,
the
I
answers?
mean, come on. I have been working on this with you guys, yes.
Okay.
Whenever you use a tool, cite it. Tell us what did you use? How did you use? Explaining, you're using the signal in your car to tell us that, oh, I'm turning this way, I'm turning that way.
Okay, sounds good. Thank you.
Will
Any
we
other-
need, excuse
Sure.
me, will we need to show that the function is 0 over 0 like you did? Like,
The first part.
yeah,
Um,
Is it
you
necessary?
are going to do that anyhow, yes?
Mm-hmm.
Why not showing it?
Yeah,
Yeah.
makes sense.
No, okay, so let's be very practical. I'm not saying these things because I want you to write more. What the reason I'm saying here is this is key point, yes? 0/0. You have to identify this is 0/0. A little bit of work may show, or you can just write with the simple thing that by substitution, polynomial substitution law, we see that it's 0/0. It will be very helpful to have a small thing writing that. But do you need at this level write all the details as I did? No, if you could have written a short thing that using polynomial substitution for the numerator and the denominator, we see that the both numerator and denominator has limit 0 as x goes to 2. That would be a good thing as well.
Okay, thank you.
You're welcome. This is not the only way to do this. Actually, I like the other way more because it is kind of so you see we started limit, yes, and then we went to continuity, and then we went to the derivative case. Now we have developed all rules for differentiation, yes, derivatives. If I can make sense of this limit, so let me write method 2, and then we go from there. So in method 2, I want this, I want to see this as limit of, see this, the limit that defines the derivative of a function at some point. I like this method not to be mathematically correct. This is a logical loop I'm creating. But what I'm trying to explain here is that you have now more than one tool to deal with questions like this. If I can see this as derivative of a function, then I can go ahead and use my differentiation skills and write it as the value of the derivative at a given point. But let's see, what does this mean? What do I need to do? I need to write this as, this was one of the definition of the derivative of a function at a point. F at x minus f at a over x minus a as x goes to 2. Here, since x goes to 2, so that means that, yes, I'm trying to find derivative of a function. If I find what that function is, and if I can find what is that uh, point, well, already I mentioned 2 is, then I have, this is nothing but f prime at 2, yes. But the main question is that, what is f at x? How about I give you maybe 10, 20 seconds to try to chew this idea, see if it makes sense to you. And what are we looking for here now? Okay. Before I move, can I ask if there is any question before I show the work here? Okay, so we are looking for a function. When we plug x equal f at x minus f at 2 will be the numerator of this thing. The denominator is already there, so I can try to just get that one done. Well, one very determining fact here is that f at 2 is going to be a number. F at x is the part which is the function. Which is the function. So here, here we are looking at this thing, and I see that, oh, look, there is something here. Take all the x terms, and if I set f of x equal to x minus 2 to the power 5 plus 5x squared, then I have to check the second part. If that is f at 2 is, well, look, this is 0. This is minus 20. It's negative 20. Wait, sorry, this is plus. It should not be negative. This is plus 20. Yes? So that is what we were looking for. We were looking for a function such that f at x minus f at 2 is the whole numerator here. And specifically, f at 2 is 20. That is what we are looking for. Well, once you understand what's going on there, you actually do not need to do lots of work there. What you need basically to do is put together all the x values as the value or as the f of x, and then since you get 0 over 0, the constant part should play the role of minus f at that point. Okay, so then what we showed here, sorry, what we showed is this, that this limit is the derivative, is the limit that gives us f prime at 2 for what? For f at x being this guy. So the limit is the derivative of this whole thing, x minus 2 to the power 5 minus 5x squared minus, well, not minus 20, prime at what point at x equal to 2. Now we have to differentiate this. This is generalized generalized power rule or power plus chain rule. That will be n u prime u to the power 1 less plus that's product and power rule. Yes, that's 10x. And I have to plug in x equal to 2. Well, see, x, this guy is 1. So I have 5x minus 2 to the power 4 plus 10x. X is equal to 2. And when you plug in, you get 2 minus 2 to the power 4 plus 10 times 2. And that is 5 times 0 plus 20. That is just 20. That is another way of, in other words, we found that this is 20. Another way of finding that limit. Any questions, any comments there?
Will we ever be asked to use a specific method, or can we just use whatever?
Unless it is specifically said something. For example, that this portion, someone may ask it this way. I'm not saying this is a part of the examiner, but this could be a part of the question that write this limit as the limit that defines the derivative, yes? And then evaluate.
All right, thank you.
Any other questions? Any other comments?
Is this just the same as doing Hopital's rule?
L'Hopital's rule basically is a bit more general than this, but this is the starting point of L'Hopital rule, or understanding the idea of L'Hopital rule. But L'Hopital rule is way stronger than this. Do you want to an example? No, I think there was actually there we go. We can do this example also that way. So then I will move to the other one, and then I'll ask you to do either way that you want. Again, I'll give you just 1 minute to just wrap up things, and then we go from there. Okay. So I'll go again 2 methods, but this time I'll go a little bit faster. So using all the limit laws, we get 0/0. So I'll try to resolve this, but this is the type of the case, a case that to be able to factor out the vanishing factor, we have to multiply both numerator and the denominator by the conjugate of the numerator, or this irrational part. So then this gives me limit of x goes to -4. So this times that. So these two are conjugate of each other. In other words, you're trying to run the a plus b or a minus b times a plus b identity, and that would be the first one squared, which is x squared minus 7, minus second one squared, which is over x plus 4 times root of, oh, sorry, I have to put that in bracket, x squared minus 7 plus 3, yes. Now, the numerator now has x squared minus 16. Well, if I write this x squared minus 16 up there, I can now factor x minus 4, x plus 4, and then divide by x plus 4 times x squared minus 7 plus 3 as x goes to negative 4. Yes, the vanishing factor, remember, is always x minus a. Here, this is x minus negative 4, which is x plus 4. That's why we have to cancel this and that. And that gives me limit of x goes to negative 4, x minus 4 over x squared minus 7 plus 3. And this is quotient law. This is limit of x minus 4, x goes to negative 4, limit of x goes to negative 4 of x squared minus 7 plus 3. And then I'll write very general again, limit laws. It gives me substitution rules, whatever you take. It is minus 4 over minus 4 squared minus 7 plus 3. And that's negative 8 over, so that's 16 minus 7, that is root 9, which is 3 plus 3, yes. And that gives me negative 8 over 6 or negative 4 over 3. Let me do quickly this in the other method as well, because that is also a good practice, because you need to know the limit definition of the derivative, yes. So I want to say that this is, see, this is f at x. This is f at 4. This is x minus negative 4. So this, if I want to write, this is nothing but f prime at 4, where f at x is root of x squared minus 7. How can I find derivative of this guy? Well, the derivative of this, recall that square root of box prime is box prime over 2 root box. So f prime here is box prime negative x squared minus 7 prime over 2 root x squared minus 7. Then I have to plug in x equal to 4. Or, sorry, x equal to negative 4. Why I'm writing that? This is negative. Negative. Yes. And that is 2x over 2 root x squared minus 7. X is equal to negative. And that is 2 times negative 4 divided, yes, divided by 2 over negative 4 squared minus 7, which is minus 8, 2 times root 9, and that is negative 4 over 3. That is method dot. Any questions? Any comments there? Yeah, I'm seeing chats a little bit. Yeah, Lobtaro, I thank you. People are answering good there. Lobtaro rule is not allowed yet. That's topic that we will cover after words. And then can we just say limit laws? Sometimes you can say just describe it and so on. Yeah, that's good. And yes, you have to report 0 over 0. Okay, then I'll move to this other question. Why am I zooming out? Okay, so let's do this question. Let's see how this comes down. Again, I'll give you 45 seconds, 1 minute, just to see how are things, and then you go from there. We go from there. Okay, so here, so you know that the function 7 to the power x is continuous, yes? When you deal with continuous functions, limit of f of x, or f of, in general, f of a box as x goes to a is equal to f of limit of box as x goes to a. When f is continuous at limit of box as x goes to a. So in this case, 7 to the power x is continuous everywhere. And now I can go ahead and say that, okay, then I can rewrite this limit in a different, in a different way. It's enough to calculate limit of this denominator. Sorry, the exponent, the power there, yes, from the left. Now, this guy is, well, look, it's substitution rules, substitution law. You use it, and then you get 0 in the numerator, 0 in the denominator. So we are dealing with 0 over 0. So 0 over 0 means that I have to resolve the indeterminacy 0 over 0. So here I can factor, I can, oh, this is nice factoring. X minus 1 to the power 2. This guy is 2 numbers. Oh, we did already this kind of factoring. And now this one of these cancels with that, and then we get to limit of x minus 2, x minus 1 as x goes to 1 from the smaller numbers. Yes. Now, here, what we need to note is that, okay, I want to use quotient law, so the limit of the denominator, oh, it goes to 0. And limit of the numerator actually goes to -3, yes? So it is an infinite limit. Oh my God. So what I was doing here was not going to work, because if it is, if continuity means that you're getting to a point, but in this case, now we got infinite limit. Can anyone tell me if this is a positive infinity or negative infinity? is the result of this limit is positive infinity or negative infinity?
Positive infinity,
How do you see that?
because x is approaching 1 from the left, which means that it would come from a negative number, I
That is,
think.
yeah, I will roughly write it that way, yes. So it is the denominator approaching to 0, but using numbers less than 0 because x is less than 1, and it is a negative number approaching to 0. Numerator is another negative number. That's negative times negative, so we get plus infinity. So what happened here was limit of 7 to the power box as x went to -1 is like limit of box going to plus infinity 7 to the power box. I'm kind of using substitution for limits, but that's basically based on this fact here. 7 to the power box as x goes to plus infinity, or box goes to plus infinity. What is the value of that limit? Seven to the power x is an exponential function with base bigger than 1. So when x goes to plus infinity, that goes to plus infinity. So the whole limit is plus infinity.
Professor, you know how you wrote -3/0? Shouldn't it be -1/0?
Oh, you're right. Yes, thank you. So but the answer is not, I just,
Yeah, the answer's still the same. I
yes,
know.
it's
I'm
still
just
the same.
yeah.
Thank you very much. Yes, you're right. That's negative one. That's right. Well, if this limit was, it is an interesting question if you go from the to 1 from positive side. In that case, your limit, your exponent is going to go to negative infinity because here, see what we had here is going to be plus 0. So -1 over positive numbers that goes to 0, that is negative infinity. And in that case, basically, we are trying to deal with this other side of this guy. When x goes to negative infinity, that guy is 0. So similar calculation shows. Okay. Any other questions? Any other comments?
I just had a quick question about what you did at the beginning. Like when you said that 7 to the power x is continuous, how did
Yes.
you like then determine that like the limit was also continuous? Like I didn't get how you made that.
No. Okay, so sorry. I did write this. I didn't know actually. I forgot that this limit up here is infinite limit. If it was a number, so what I was trying to say that if that limit of the function up there was a number as x goes to a, then you can do this.
Oh, okay.
Yes, if the limit of f of x as x goes to a exists, then you could have taken basically limit into the power there. Yeah, does that make sense?
Okay, but we didn't do that because it was an infinite
Because
limit?
yeah, I didn't know that this is going to be infinite limit, and so in infinite limit, the story is different. So this is how we dealt with, yes, that
Okay.
as x goes to 1 from -1, that power part goes to plus infinity, and then from there you get the plus infinite limit.
Oh, okay, okay.
Yeah.
And then if we were given a case like where it wasn't an infinite limit, we could just do like the top part that you
Yes.
showed, and
So
that
there, then the reference that you have to give is this, that
okay.
7 to the power x or exponential function is continuous everywhere. So we can switch the order of limit and the function.
Oh, okay, okay. Thank you.
Okay.
Sorry, one more quick question.
Sure.
When it's -1/0, if it was just 1/0 from the left, we would still get positive infinity, right? Because it's still like if the numerator was positive.
Yeah, so if numerator was say +1 and then the denominator approaches to 0 from the left, so it is positive times negative, it will be negative infinity. But in this case, it was negative times negative, so it gave us negative. Sorry, positive infinity gave us, yeah. Was that the question? Sorry, maybe I missed.
Yeah, so if it's just 1/0 from the left, would we still get positive infinity?
No, it will be negative infinity in that.
Oh, okay, okay.
One is positive. The values in the denominator are negative, so it is you're approaching negative number, or you're going to negative infinity.
Okay.
Okay, then let's move to the other question. Maybe I should can add a little bit of speed there, but this is okay. This is a good question. I like it. I don't know. Let's do this. Again, I'll give you what a minute just to start the thing, and then I'll go and complete. So here we have to be a little bit okay. Come up with a good way of presenting this result. But what you need to know is that there are two pieces in this limit that you should focus on. This is one, and then this is the other part. Yes. Now, if this part has if this part has a limit, I already know that this part will have the limit. So we will go ahead and then use product law and then find the whole limit. So that means that for a moment, I can drop this and try to see. I'm not saying this is the value. I'm just trying to see. Yeah, let me maybe write in a sentence. First, let's evaluate the limit of absolute value of x minus 1 over sine of x minus 1 as x goes to 1. And why is that? Because that is how you will be able to use product law, and then you can evaluate this part, you evaluate that part, and then you multiply. Yes. But this is our friend. This is the limit of sine box over box as box goes to 0. Oh my God. No, there's an absolute value there. Then since absolute value of x minus 1, remember, absolute value is a piecewise defined function. And here you should say that, okay, if x minus 1 is bigger than 0, then it will come out as x minus 1. As x minus 1 is less than 0, it will come out as the negative of that. In other words, this guy is x minus 1 if x is bigger than 1. Oh, I can include 0 there. And 1 minus x if x is less than or equal to 1. And that is important for us because we're approaching to 1. Yes. And then the function is piecewise defined function broken as we get to that point. So the limit point as x goes to a, that is the point that your piecewise defined function is broken into two pieces. So that means that if you want to take one thing about piecewise defined functions with you to the exam, is that when you limit, you're trying to find the limit of a piecewise defined function, the right approach is to find them, to find one-sided limits. So is this over sine of x minus 1 as x goes to 1 plus 1. So if I approach to 1 from the positive side, absolute value of x is nothing but x, sorry, absolute value of x minus 1 is nothing but x minus 1. So in that case, so we come down to this fact here, yes, and that is going to be limit of 1 over sine of x minus 1 over x minus 1 as x goes to 1 from positive side. That guy is equal to 1 over 1. So this is quotient law. This is this law here. So as x approaches to 1 from the right, the limit is 1. As x approaches to 1 from the left, remember that negative sign. I'll keep it that way so that you see what happens there. This is a limit of negative stays up there, sine of x minus 1 over x minus 1 as x goes to negative 1. And then quotient law, it will give us negative 1 over 1, which is negative. Well, how did you know to split this to plus the positive limit from right, limit from the left? Because the function was piecewise defined. Then we had to do this. Now what are we going to decide, or what is the final answer? The right limit and the left limit, both of them exist, but they are not the same as x goes to 1. That means that the limit, the actual limit, not the one-sided limit, does not exist. Okay. Well, it does not exist. How do you know that this is not going to work for the rest? The point is that now, this is the interesting part, that the first part, note limit of x squared minus 3 as x goes to 1 exists, and it is equal to negative 2. The first part exists, the second part does not exist. So since this guy is not 0, then you can imply that the whole limit is not 0. It does not exist. Or another way of saying that is this, that let me, before I repeat that last piece, ask if everything makes sense so far, or is there any questions so far?
If the limit of the x squared minus 3 was 0, would it make the whole limit 0 since it's 0 times like PNE?
You had to be a little bit careful there. So in that case, you had to figure it out properly if this is going to be 0 or not. In this specific case, that would have been, if that was the case, then the limit would be 0. But how to write it, it would be a different game, different story.
All right. Thank you.
What I mean is this, maybe I can say it a little bit differently. So for example, if this was limit of x absolute value of x minus 1 to the power 3 over sine of x minus 1 as x goes to 1. Yeah. See, x minus 1 cube absolute value. So instead of having x squared minus 3, I added another x minus 1 squared, yes? So in that case, if you split this up, then you get positive side limit, and then you get x minus 1 squared over sine of x minus 1 over x minus 1. Now you can use the quotient law. This will be 0 over 1, that is 0. The left limit would be x minus 1 squared over sine of x minus 1 over negative x minus 1. Yes, so maybe I should have put this negative up there. So that would be quotient law, and it will be negative 0 over 1, which is 0. And then in that case, yes, that will be limit is equal to zero. But you cannot go ahead and say that, oh, this is 0. This limit does not exist. When you multiply, it would exist. So no, that's a tricky thing. For example, the other side could be infinity case. So 0 times infinity, we will study this in a little bit more detail. 0 times infinity is going to be another indeterminate form, and we have to handle it properly. Did this answer your question? What?
Yes, thank you.
So again, the key point is that you cannot in general say that since this part has limit 0, the other side has limit does not exist. When you multiply 0, it would be does not exist. That's not a good mathematical argument. In those cases, you have to see how the whole thing works. Sometimes you do this, sometimes you may do squeeze theorem, and sometimes other stuff. Yeah. Any other questions?
Yeah,
You know what?
could you just explain? Oh, you can
Yeah,
go.
go ahead, please.
How come we want the x squared minus 3 to equal 0?
What do we get out of that if equals 0?
No, that was a question that your classmate asked. Is this because x squared minus 3 is not, the limit is not 0? That's why it doesn't exist? If it was 0, would that make this whole limit exist? My answer was it depends on what is the situation. You may need to do some general work. You cannot just say that this is 0 times does not exist, so it must be equal to 0.
I see, okay.
Yeah. There was another question also.
Yeah, could you just explain how you got from x minus 1 over sine x minus 1 to limit of x to 1 and then 1 over sine x minus 1 over x minus 1?
This part you mean? Sorry, let me see if I can circle this. Yeah. Do you mean this?
Yes. Yeah.
So this is just a work, yeah? So you have, so it's not about limit. It's a over b is 1 over b over a.
Oh, okay.
Yeah, I'm just taking this down there, yes? Okay. One way of saying that the whole thing does not exist is this, that limit of x minus 1 over sine of x minus 1, we already saw that this limit, if so this limit is the same thing as, if it exists, is this times x squared minus 3 times x minus 1 over sine of x minus 1. X goes to 1. Yes, I multiplied and then I used the product law. I separated, but I know that this number is 1 over what? Negative 2 limit of this whole thing. Yes. And this is just a number. The scalar multiplication doesn't change anything. Now, we have shown that this guy is a multiple of that. If this one does not exist, the whole thing on the right-hand side does not exist. And that's another way of saying it very mathematically and quick. Let me move to the other question. We have to do a little bit more. Oh, we have horizontal, vertical as well. Yes. Let's do this one. I will give you 30 seconds. Just start thinking about this, and then we go from there. Okay. Does anyone have the answer for that? If I know that limit, oh, wait a minute, I didn't write this, sorry. If we know that, sorry, this is not it's not written complete here. I should have said that if limit of f of x plus 3x minus 5 over x minus 2 as x goes to 4 is equal, say, to e, then find limit of f of x as x goes to 4. Now I should maybe give you a 30 seconds to think about this before I say it. Oh my God, there's a typo again. This is 4. This damn thing should go. Another 30 seconds. Okay, does anyone have an answer for that?
I'm just wondering, can we use IVT in this situation?
IVT. IVT is about the values of the function, yes. This is about a limit. So IVT is a little bit, yeah, different here.
All right.
It was a good guess, at least starting. Yes. Any other suggestions? So look at this. I claim that limit of f of x plus 3x minus 5 as x goes to 4 must be 0. Why? Well, if you think of this problem, the way we worked on these kind of questions, you see that the limit of the denominator is 0. Yes. If the limit of the numerator is not 0 number, then this would have been infinite limit, but this limit exists and it is equal to e. So that means that we had a 0 over 0 case, and then we resolved it to get a value, not infinite limit or existing value. Another way of saying that is that limit of f of x plus 3x minus 5 as x goes to 4 is the same thing as limit of f of x plus 3x minus 5 times x minus 4 times over x minus 4. I can multiply and divide the thing over there, yes? And then this is the same thing as limit of x minus 4 times limit of f of x plus 3x minus 5 over x minus 4 as x goes to 4, as x goes to 4. And here I use product law, yes? But the first one has limit 0. The second one is given its e. So the whole thing must be 0. So that is a bit more mathematical way of saying that. So if the limit of this guy plus 3x minus 5 is equal to 0 as x goes to 4, there is a little bit of mathematical argument, but here you just say that some law says that limit of f of x plus limit of 3x minus 5 as x goes to 4 must be equal to 0 as x goes to 4. And as a result, limit of f of x as x goes to 4 plus, just plug in the values. This is limit law, polynomial substitution law, and that is 3 times 4 minus 5, and that must be equal to 0. So that means the limit of f of x as x goes to 4 is equal to, well, or this way. This plus 12 minus 7 minus 5 is 7. So plus this is 0. So that means that limit of the function as x goes to 4 must be negative 7. The key point is to understand that the only way for us to get a value there is that we get the limit of the numerator must be 0. If it doesn't exist, or if it is something not equal to 0, this limit wouldn't have exist. That's the key. Any questions? Any comments here for me? Okay. And let's go. Oh, I have 3 more questions for limits, which is a good review stuff. Like it. Like it. Okay. I think we did an example in class similar to this, yes. So here is this is a function that is defined a bit strange. Actually, it is similar to one of the questions in the textbook. So it says that on the rational numbers, it is absolute value of x. On the irrational numbers, it is this upside down parabola minus x squared. This is absolute value of x. But there are so many of rationals and irrationals. If you plug this function, it will look basically to computer like a continuous, like a line kind of thing. But in what is happening here is that this whole thing is full of these holes where it's rational, it is not irrational, and only one of these guys is taken at each point. Now, how are we going to use that to find f of x? I can see f of x is a piecewise defined function, yes, but it has either values absolute value of x or values negative x squared. I know that absolute value of x is bigger than x squared. Look at this guy. This is negative x squared, negative x squared, and this is absolute value of x. Absolute value of x is always bigger than negative x squared. But my function is either taking that value or that value. So then the function is between those two things, or all x in real life. Now this negative x squared here is not the same one that was there. That was when x is irrational. That was negative x squared. This negative x squared is everywhere negative x squared. So we have limit of the smaller number as x goes to a smaller function is equal to negative 0 squared, which is 0. Limit of upper function, absolute value of x as x goes to 0. This is also 0. Now look, I showed that my function is between two other functions. I showed that the lower function as x goes to 0 has limit 0. I showed that the upper function as x goes to 0 has 0 limit. Then by 1, 2, and 3 triggers squeeze theorem. As a result, the middle function, which is our function, will have limit 0. And that is one of the good applications of squeeze theorem. We set it up. We set up an inequality such that our functions between two other functions. We showed that the lower function or the function on the lower end has limit, upper one has limit. They are the same, yes? Then squeeze theorem says that the middle one should have limit and its limit must be equal to the limit of the other ones as x goes to 0.
I just had a quick question. For part one, why is our function like in between those two boundaries?
So see, f of x, either x is a rational number, then f of x will be absolute value of x, or it is irrational number, it is negative x of x squared. So it has no other way, other things than these two rules. Now what I'm saying is that if your function is either taking that formula or this formula, then the whole function is less than this upper one and bigger than the lower one. In other words, the graph that I draw you here, you say that, okay, see this function, the solid one, my function never goes beyond these two solid functions. My original function is somewhere, so many places it has holes, but this x squared and absolute negative x squared and absolute value of x, they are solid function, and our function is either taking that value or that value. So it would be between those two. There's no other values there.
Okay, thank you.
Any other questions? Any other comments? Okay. Let's go back to do this question. Oh my God, why my T's and F's are all mixed up. So here the function is f of x is absolute value of 9x squared plus 2x minus 1 over x minus 3. The question says find horizontal asymptotes. I'll give you a few seconds or 30 seconds, and then you do the rest. So for horizontal limits, we have to find as x goes, the limits as x goes to plus infinity and as x goes to negative infinity. So these two we have to figure out. Remember, when x goes to plus or minus infinity, you have to factor out the dominant term. In the case of polynomials, these dominant terms are the terms with highest power. And in the both cases, actually, I'll write this in the middle so that it comes together. So in both cases, the dominant terms are the same. So I factor out x in the denominator. That comes out, and then there is 1 minus 3 over x. In the numerator, you get x squared 9 plus 2 over x minus 1 over x squared. As x goes to either plus or minus infinity. So far, I'm just factoring out the dominant term, the term with highest power. Now, and it doesn't matter if it is plus infinity or minus infinity. Now, I try to separate this because I want to cancel, yes? This gives me this guy, square root of x squared, and then 9 plus 2 over x minus 1 over x squared. And then down there is this guy. And, well, we know that absolute value of box squared is, sorry, the square root of box squared is absolute value of that box. So in this case, we end up getting absolute value over there. And we get this. So now when we have absolute value, either we're going to plus infinity or we are going to minus infinity. So here now I have to separate. So if it goes to plus infinity, absolute value is x. Absolute value of x is actually x. And then I can cancel these two and then find the limit of this guy. But then limit laws says that, okay, so here it will be 9. Limit of 2 over x as x goes to 0. Sorry, x goes to plus infinity is 0. That other one is 0. This is 1. This is 0. So it will be root 9, which is plus 3. If I go with the negative infinity, absolute value of x is negative x. So when I cancel x's here, there will be an extra negative sign up there, and then using limit laws, I will get minus 9 plus 0 minus 0, 1 plus 0. And that is negative root 9, which is negative 3. This means that we have two horizontal. F has two horizontal asymptotes. X, sorry, y equals to 3 and y equals to negative 3. Does this make sense? Or any questions?
So when x approaches negative infinity,
Yeah.
I think the x in denominator should be negative, and the upper one is positive, right?
No, in the denominator, I have just x, yeah? So I have x minus 3. Doesn't matter x is positive or negative. I can factor out x and I'll get this. Doesn't matter what is the value of, I mean, x cannot be 0, obviously. We are going to plus or minus infinity. If you set that aside, this is true for all x's but 0. And it doesn't matter if x is negative number or positive number.
Okay, I see. Thank you so
Yeah,
much.
does that make sense? Yeah. Keep the difference between the numerator and the denominator is this, that in the numerator, the highest or the what's it called? The dominant term is coming under the square root, and the square root of x squared is absolute value of x. And then, yes, for absolute value of x, positive or negative changes the game.
Professor, for these type of questions, we always grab the highest power denominator, right? For x.
Both denominator and the numerator.
For both?
For both, yes. So
Okay.
like this is, you see, it is kind of when you find the limit. In the numerator, you get infinity. In the denominator, you get infinity. This is another indeterminate form. And to resolve indeterminate form, infinity over infinity, you have to factor out the dominant term in the numerator and factor out the dominant term in the denominator. Yeah, does that make sense?
Yeah, that's good. Thank you.
I have a question. If when we were like factoring the square root of x squared, if we just wrote x to the power of 2 over 2, do we still need to indicate that it's an absolute value of x?
Sorry, again, so you factor out x squared, yes?
Yeah, and then that will become x to the power of 2 over 2.
Oh, no, so this is the right way of seeing it. If you do, if you write this for square root, then you're ignoring that box can be negative number. So you can write 1 over 2 if you know that the box that you're dealing with is positive number.
Okay.
Yeah.
I'm sorry, just a follow-up. So if I was solving this just for the positive side, I won't have to do the root absolute value. So let's say if I was solving for the negative.
Okay, so
Yeah.
here is the dangerous thing that you're now trying. In one case, coincidentally works, you should not trust it.
Okay.
I think what you should try to do is actually this, and that's absolute value. You should do that all the time. But when it is positive infinity, that absolute value is nothing but x itself. Yeah.
All right.
I mean, I'm just saying this because that will give you the tricky points there. Yes. If you don't check this separately, or if you don't do the absolute value, you may not be able to track it down in the required cases.
Okay. Thank you.
Any other question?
Professor, just want to ask that when we're working with limits as it approaches to infinity, do we have to also know when when it includes like sine, cosine when working with infinity?
Yeah, there could be. Like, I mean, look, limit of, sorry, for example, someone can ask you this question: what is limit of sine of x? Let me see, sorry. Yes, for example, this. Yes, for example, this. This is a question, yes.
Okay.
Can anyone tell me what is the answer for this limit? Either positive or negative, doesn't matter. This is the same thing as limit of t sine of 1 over t as t goes to 0, either plus or minus. And by squeeze theorem, this is equal to 0. Yeah, I think we have done the squeeze theorem for that one, so you should be able to see that there. Okay, so I will actually jump to the derivative section because we don't have much to do. The derivatives. Okay, let's start with some differentiations. Yes, you have to start working with the derivatives. I will try to go ahead with these ones, quickly differentiate because this is how you need to know how to deal with these derivatives. Yes, here you're trying to do derivative of um, chain rule plus power rule. When you find the derivative is n box prime box to the power n minus 1. So in this case, f prime of x is 10 x4 minus 4x cubed plus 3 prime x4 minus 4x cubed plus 3 to the power 10 minus 1, 9. And then you just need to find the derivative of that part, which is this minus 12x squared, x4 minus 4x cubed plus 3 to the power 9. Okay. This other one, the function is e to the power x plus 4 sine of x to the power 1/3. So then f prime of x is going to be 1/3 e to the power x 4 sine x prime e to the power x plus 4 sine of x to the power 1 less. And here I get, this is a negative number, negative power here. So it will go down. So there's a 3 there. E to the power x plus 4 sine of x to the power 1/3 minus 1 is negative 2/3, and that is 2/3 in the denominator. However, I have to find the derivative of this. Derivative of e to the power x is e to the power x. Derivative of cosine x is cosine x. This function here is x squared plus e to the power x plus cosine x to the power negative 4. So then the derivative is going to be negative 4x squared plus e to the power x plus cosine x to the power negative 4 minus 1. Oh, sorry, prime n box prime box to the power 1 less. And that would give us minus 4 times 2x plus e to the power x minus sine x over x squared plus e to the power x plus cosine x to the power 5 in the denominator. Cosine of u, the derivative of cosine box is box prime minus box prime sine of box. So f prime of x is minus x squared minus sine x prime sine of x squared minus sine x. And this is minus 2x minus cosine x and sine of x squared minus sine x. And this guy, so the derivative of cotan box is minus cosecant squared of box. Oh, I have to multiply. The chain rule is there, box prime. So f prime of x is derivative of box. Here, box is this guy. A minus there, cosecant squared of box. Okay, now I have to find derivative of sine of x squared. But derivative of sine box is box prime cosine of box. So this will be minus x squared prime cosine of x squared cosecant squared of sine of x squared. And well, that is minus 2x cosine of x squared cosecant squared sine of x squared. I don't know why I chose black marker here. Everything is now black. It's very difficult to read. This for myself. I will make it all blue. Any questions there? Any? Okay, then let's do a few more. Sine inverse, the derivative of sine inverse of box is box prime over 1 square root of 1 minus box squared. So f prime of x is equal to box prime root x prime over root of 1 minus root x squared. And that is derivative of square root is 1 over 2 root x, 1 over root of x squared is root x squared is x. So we have 1 over 2x 1 minus x. So this guy is x plus tan inverse of x to the power negative 2. So the derivative is negative 2 x plus tan inverse of x prime x plus tan inverse of x to the power negative. But then that thing is 1 plus 1 over 1 plus x squared. The derivative of tan inverse is 1 over 1 plus x squared, or x squared plus 1. And then x plus tan inverse of x to the power negative. F prime here. So this is cosine inverse of box prime is negative box prime over 1 minus box square root of 1 minus. So here you get sine of x prime over square root of 1. Oh, there's a minus sign there. For cosine inverse, you get a minus sign. Over square root of 1 minus box square. And then derivative of sine x is cosine x. And here down there is 1 minus sine squared, so it will be cosine squared x. Well, cosine squared comes out as absolute value of cosine x, so we get absolute value, so yeah. Now, f prime x is derivative of first one, cotan inverse of x squared times sine x plus cotan inverse of x squared itself times the derivative of sine x. And the derivative of cotan inverse of box is minus box prime over 1 plus box squared. And that tells me that this part is negative 2x over 1 plus x squared squared cotan inverse of x squared cosine x. Sorry, I have been going a little bit fast, but these are just wanted to tell you that these are the differentiation rules. You have to know how to deal with these cases. Any questions, any comments for this one?
For the first one on the second example, isn't it
Mm-hmm.
one? I mean for the second example, like the one with the
Oh,
inverse.
okay, yeah.
Yeah. Isn't it 1 over 2 square root x multiplied by square root of 1 minus x? Because it was 1 over 2.
Yes, you're
Yeah.
right. That goes down. Yes, that's what you mean. Yes.
Yes.
That's true. Yes. Thank you.
Okay, thank you.
Any other comments, questions? Okay, then let's go and do some more derivative questions. I will start with this one. So find the, what is this? Find the equation for tangent line for this guy, for this function, for the graph of cosine inverse x plus x minus 2 at x equal to half. I'll give you a few seconds. I actually charge my phone. Yeah, just start this. Give me a few seconds. Let me just take I'll come back in a minute. Sorry, guys. It took me longer than. Okay. Do you see my screen? Why my screen is not shared again? Okay. Oh, no, no, no. Okay. Let's see. Okay. So back to here. So what we need to know here is that the slope of tangent line at that point is equal to the derivative of that function at that point. And the point of the tangent is going to be half, that's x value. Y value is when you plug in half into your function. So let's first find what is f prime. F prime of x is derivative of cosine, which is negative cosine inverse, which is negative 1 over 1 minus x squared. And then as a result of that, f prime of half is nothing but negative 1 over 1 a. Wait, there's an x minus 1. Damn it. Plus 1. That's the derivative of x. Minus 0. 0 is the derivative of 2, so I don't need. That means f prime at half is negative 1 over 1 minus half squared, which is 1 over 4, plus 1. And what is this number? This number is negative 2 over root 3 plus 1. That's this slope. But I need to find what is f at half. So it is cosine inverse of half plus half minus 2. What is the angle whose cosine is half? That's pi. Sorry, it is pi over 3, and that is, wait, what is that? That's 3 over 2. So that is my point, half and pi over 3 minus 3 over 2. This is the slope, so it is going to be y minus pi over 3 minus 3 over 2 equals m, which is negative 2 over root 3 plus 1 times x minus x0. So this is the general form. Let me find that. Yep. Any questions? Any comments for me there? Sorry, guys, I have to do something before. I am so sorry. I have to change something. You have shown at least this question. Okay. Yeah, you start working on that. I'm so sorry. Something a little bit priority happened. I'm sorry for this. I had to do something there. Okay. So I want to see this as derivative of a function. Remember, limit of f of x minus f at 1 over x minus 1 as x goes to 1 is, if it exists, is f prime at 1. Here I have f at x. Hopefully this is f at 1. Hmm, sorry. So yes, so here I have to check f of x is tan inverse of x minus x cubed. Actually, why do I put 1 there? Doesn't matter. This function, you can add any constant to it. Still, it will work. With or without 1, it would work. But if you include 1, then f at 1 is supposed to be pi over 4. And yes, f at pi over 4, we have to check tan f at 1, sorry, f at 1 is supposed to be tan inverse of 1 minus 1 cubed plus 1. That is pi over 4 minus 1 plus 1. That is pi over 4. And that's what we were expecting. So that means that limit of tan inverse of x minus x cubed plus 1 minus pi over 4 over x minus 1 as x goes to 1 is nothing but f prime at 1. Well, if someone is asking you to evaluate that function, then you just need to say, okay, so this is f of x is this guy, so then the derivative is going to be 1 over 1 plus x squared, that's derivative of tan inverse, minus 3x squared plus 0. So f prime at 1 then is 1 over 1 plus 1 squared minus 3 times 1 squared. And that is nothing but 1 over 2 minus 3, which is 2, 1 minus 6, negative 5 over 2. That is the value of the limit using the definition of limit there. Any questions? Any comments? I'm sorry for being distracted for this. I had to deal with it because it was a kind of emergency. Any questions? Any comments there for me? Okay. I would say take a screenshot of this. This is just use the differentiation rules to evaluate to find the derivatives, and that is what it is. I think I will try to finish this soon. I want to do one or two more things, at least a few implicit differentiation question. That one I don't want to do. Yes, okay. Implicit differentiation. Yes, okay. Remember, implicit differentiation, when you're doing it, you have an expression, an equation in terms of x and y, and you want to take the derivative with respect to x. So in this case, what you do is you go ahead, derivative of left-hand side. I will write with details this one, and then I'll leave with less details. Then you use differentiation rules. Yes, the first one is 2x minus. The second one, we have to use product rule. The derivative of first one, the derivative of y squared is not 2y. You have 2y prime y times second one plus the first one times the second one. The derivative of x is 1. And here you get 3. Then you get 2x minus 2y prime yx plus y squared equals to 3. Once you did that, you have an equation for y prime. You have to solve it. So in other words, keep the terms with y prime one side and send everything else to the other side, and then divide the coefficient of y or y prime to the other side there, which is that. And I'll do quickly these ones. So here I have to use the quotient rule, derivative of numerator times denominator minus derivative of the denominator times numerator over the denominator squared equals the derivative of that, which is 3, derivative of 3x plus 1 times cosine of 3x plus 1 minus 0. Well, the derivative of 3x plus 1 is 3. So the right-hand side here is 9 cosine of 3x plus 1. Now I have to solve it for y prime. Yes, sometimes it is not straightforward. You multiply that y squared to the other side. And then take the term without y prime to the other side. Then divide the whole thing by the coefficient of y prime. And that's it. This other one here, e to the power x squared minus y squared. So the derivative is derivative of x squared minus y squared, e to the power x squared minus y squared times derivative of first one times second one plus first one itself times the second one prime. This guy here is 2x minus 2y prime y e to the power x squared minus y squared. It's y plus x y prime. Now we have to find this y prime. Let's expand this. So this is 2x e to the power x squared minus y squared minus 2y prime y e to the power x squared minus y squared equals to y plus x y prime. Yeah. And now I have to take the terms with y prime one side. So it is x y prime. I will take this to the other side and write left in the right. So 2y prime y e to the power x squared minus y squared equals 2x e to the power x squared minus y squared minus y. Now, if I factor out y prime, then I can divide this to the other side. And that is y. Well, let me don't rush. I know that this is the end. I will get this one done and then use the technology for this. I'll go like that. Copy, then do paste, and then I'll take this one, then say that, okay, this is what I will do. I'll take the coefficient, put it down there. Done. That is how you find the y prime for the implicit differentiation. I think I want to do one more example here because this is the second derivative, and then we finish. Any questions? Any comments? Sorry, I'm going very now monologue here just to get things. Okay. So here to find dy dx, you get 3, differentiate both sides, 3y prime y squared plus 1 times y product rule, x times y prime plus 2x is equal to 0. Take the terms without y prime to the other side. Sorry, this is squared, yes. And then y prime. The y prime is minus 2x minus y over 3y squared plus x. Okay. Now, the part that I want to say here is that I want to find the second derivative. Remember, the second derivative is nothing but the derivative of the first derivative. Or maybe I should write d dx of y prime. And d dx of y prime is here, minus 2x minus y over 3y squared plus x. Yes, now I have a quotient rule to apply. Derivative of numerator minus 2 minus y prime times the denominator minus the numerator itself times the derivative of the denominator. So derivative, the numerator times the, sorry. Just give me a second, sorry. Let me fix this thing and then come back. Oh my God, so many things happened during this session. Okay, so derivative of numerator times the denominator minus the numerator itself times the derivative of the denominator over the denominator squared. This is the second derivative. The only thing we should do is this, that, or I can write only just y double prime, that we have to put y primes in these spots. So in other words, I'll just try to write negative 2 minus 2x minus y over 3y squared plus x, 3y squared plus x minus 2x minus y, and then 6y, y prime is minus 2x minus y, 3y squared plus x plus 1 over 3y squared plus x, the whole thing. So I just wanted to make sure that you also see this part. This is something that I wanted to do. There's only one topic that we didn't touch based on, and it will be included in the test. That is log differentiation. Log differentiation, we have done it in class last week, earlier this week we have done. But I didn't include in our review. So make sure that you do also log differentiation for the midterm test, which is tomorrow. Well, I'm so sorry for the things happen at the end. I had to make sure that I do the arrangement for something, and it took some time off me. But I hope that at least this was a chance for you to go over some work and see some more questions related to the midterm. I will stay a few more minutes here, but if you have questions, comments, yeah, please go ahead. Then,
Sorry,